Hello students, so I'm making this video as per your request. So in this video I'll explain the training algorithm for Adaline. So before going to the training algorithm part, let me introduce you briefly what is Adaline. So Adaline stands for Adaptive Linear Neuron, which is a single linear unit neuron, or you can say network as well. It was developed by Hoff. The architecture of Adaline is similar to perceptron, just that it has an extra feedback. With the help of this feedback, it compares the calculated output with the target output, and based on the comparison, it adjusts its weights and bias. So it uses bipolar activation function. As I told you guys before, bipolar activation functions means those activation functions which ranges from -1 to 1. So Adaline uses delta rule for training to minimize the mean squared error or MSE between the actual output and the target output. And based on this comparison, it adjusts its weights and bias. So, the training algorithm. For any neural network training, you have to initialize 3 parameters beforehand. Those are weights, bias, and learning rate. So for simplicity, you just initialize weights and bias to be 0 and learning rate set to be 1. So initially, when you give training, and since it's a supervised, that means you give training data and a label. So you can represent that training pair as S and T. So S stands for score function and T stands for target value or target output. So now you activate each input xi as si, which is score functions. Here I goes from 1 to n. That means you can have n number of neurons, n number of input values to Adaline neuron. So after that, it calculates the net input to the neuron, and the equation of calculating the net input by this adder portion is like that, where yin is the net output, which is the addition of bias plus the summation of xi via xi stands for your input. I goes from 1 to n because you have n number of neurons, and wi represents the weights associated with each input values. So next, after calculating the net input, that net input goes to the activation function. Then activation function calculates the weight based on the threshold value. Here, since it uses bipolar activation function, the equation for calculating final output is like that, which I explained to you guys before. So activation function of yin, that means the net input, is equal to 1 if the net input is greater than or equal to 0. Output will be -1 if it is less than 0. Now, after calculating the output, you need to adjust your weight and bias. For that, you have 2 cases. Case 1, if your calculated output is not equal to your target value. Okay, when there is a difference between your target output or target value and the calculated output, that means the training is not proper. So main goal of a training is that the output value is as close to your target value. So in case 1, when your target value is not equal to the computed value, you need to update your weight and the bias. So new weight will be old weight plus this term. So just observe this term carefully. Your alpha is your learning weight, and here this t minus w yn is your error. Error means your target minus your calculated output into your input values. So your new weight will be your old weight plus this portion. So this particular term, this t minus yn, is specialized in case of delta rule. That means you calculate the error by finding the difference between target output and the calculated output. So accordingly, the new updated bias will be your old bias plus your error and the learning weight. Next, case 2, that means when your output is equal to target value. So when your output is same with your target value, that means what? You have reached your goal. That means there is no need to update your weight and bias values because it has already reached that stopping condition. So in this case, your new weight will be your old weight and the bias will be the old bias. So your y is your actual output and t is target output, and this t minus yi is the computed error which I explained before. So this whole steps will get into a halt when it will reach a stopping condition, which will happen when there is no change in weight or the highest weight change occurred during training is smaller than the specified tolerance. So basically in Adaline, it's similar to perceptron, just that it has extra feedback thingy. So with the help of feedback, it just compared the output, the computed output, with the target output. And with this comparison, or with using this difference, it calculates the error. Error means target minus output. So after calculating the error, it just uses this term. This is error into input into learning weight and plus the old weight. So after that you get the new weight. So this whole process, training process, continues until when your Adaline network is ready for accurate prediction or classification. So thank you. Hope you understood.